And welcome back. Now this week we're going to be catching up on this little project here, which turns out to be the Universal Timer project that we spoke about a long time ago, and that originally was going to have a processor on board, a bit like this one here. It was going to look like this. We're going to have a 328 chip in the middle and various bits, and I asked for comments, and you guys came back with lots of very, very useful stuff. So I decided to change the approach a little bit. Now, whereas the original design required a dedicated chip in here, and you said things like, well, why don't you bring out more pins and things like this? When I got round to redesigning it, I thought, well, why am I reinventing the wheel, really? Why don't I just stick a nano on here, plugged in, which is what that is, and do the rest of the circuit really to one side? A couple of you said, why don't you make this a daughter board for an Arduino or something? But I thought, well, I want to keep the thing fairly small. I could have made it a shield, I suppose. But, you know, this is the way it turned out. Now, there's the whole thing about this. We talked about the dip switches and the 7.4 HC165 at the back, which you can probably see there. Look. We talked about all that in video 161. Now, there should be a little link up there somewhere saying suggested viewing or something, but there'll be a link at the end of the video as well, right at the end. Okay, so if you haven't watched this video yet, you can find out what it's all about. Basically, it was started out life as a toothbrush timer. Here's my toothbrush. Do you know, I think I need a new head on that soon. Anyway, it's a toothbrush timer, 2 minutes. Why? Because this toothbrush is badly designed in as much that when you turn it on, fine, every 30 seconds it gives a little zzz, another sound effect for you, to remind you to move to another part of your mouth. Except if it's going on and you accidentally press this button, which I do all the time, the whole timing cycle starts again. So you could be 1.5 minutes into your teeth cleaning routine. I accidentally press this off and it goes, oh, okay, we'll start again then from scratch. Oh, drove me mad. So I thought, right, we'll throw it away and buy a decent toothbrush. Well, okay, that might still happen. But I thought, why don't I just create a simple 2-minute timer and have it beep every 30 seconds? Create it with an tiny 85 or something. Just hardwire the code for 30 seconds, beeps, the end. And I thought, well, that sounds a bit wasteful, really, doesn't it? Not sharing the stuff and making it a bit more generic. So this is where the universal timer came in. And, of course, it gave me an opportunity to show you guys the 7.4HC165, which is an 8-bit parallel load shift register. There, you can throw that out the next party. Very easy to use. And basically what it does, it reads these 8 dip switches here in parallel. So you go, read them please, and it goes, okay, I've read them in. And then you can read the value back into your Arduino or Nano, and it says, okay, all these particular bits were set or not set. And it's pretty easy to use, I've got to say. So that's a plus. Now, of course, you don't need to use dip switches. You could use pin headers and with jumpers, and we'll come on to that in a minute, because there's quite a few things on here that I'd probably do differently. And there's going to be a follow-up on this board, not for this bit, but I'm not going to have any more spoilers. We'll wait and see on that. So let's think about all the things then that could have been done differently. Now, you'll see on the workbench, I've actually got 2 versions of this board, the green and the red, and they're both made by JLCPCB. So let's have a word from our sponsor who make this video possible before we continue. I'm going to show you today the options for SMT Assembly. And there's a special offer on at the moment. There's no engineering fee, you just pay for the components used. Here's a recent example PCB that I had assembled by JLCPCB. I'm assuming you've got the board all set up like this one. All you need to do is generate 3 files. You need to generate the Gerber files by clicking on that one up there. So you click on there, it says, do you want to run a DRC check? You should always do the DRC check just to make sure everything's okay. And then down the bottom here, it's generate Gerber. Click that, say where you want them to be saved, make sure you can find them. Click save and you're away. That's the first set of files. The next file you'll need is the bill of materials, the components list basically. Click on the BOM at the top and that will export a CSV file. Ideally keep it in the same place that you had the other one. So export BOM and save it in the same place. The third file you need is the pick and place file. So go to the menu here at the top, scroll down until you see export pick and place file. Click that. You do not need to mirror the coordinates, just leave that as it is and click export. And once again, save it in the same place as you did the others. Now you've got your 3 files, you're ready to upload your files into the JLCPCB website, quote now. Once you've reached this page, add the Gerber files, which is the first set of files that you actually generated. Fine, there's the PCB, but remember we want this assembled. So scroll down the page until you hit the SMT Assembly. Click that. And it says which side you want to assemble. Well, on this board I've only got components on the top side, so we'll click that one and confirm. Here it wants your 2 other files that you generated. The BOM file, bill of materials, that's the components file, and what it calls the CPL file, that's the pick and place file. Add those 2 in exactly the same way, confirm, and you're away. Here you can see the board that I uploaded, this one here, and the assembly request here. This is for a different copy of those boards, the red ones that you'll see in the video later on. And that's it. Now it takes about 3 to 4 days to actually generate the board and assemble the components, and I tend to use the DHL shipping method because it's the quickest, but there are multiple options available to you. And there it is, very simple and easy. How can you go wrong? Try it now. Right, so why have I got 2 versions of the same board? Well, basically the green ones are assembled, partially assembled anyway, SMT components. So on it you have the chip at the top assembled for you, that's an SMT chip. These resistors are all soldered into place. That LED, there's another cap over there, and I think that's it. Now JLCPCB ask you when you submit your board, which side of the board do you want assembled, bottom or top, because they can't do both. At the moment it's a bit too complex, something they might consider in the future, but of course all my components are actually on top here, so that was fine. And the turnaround is pretty quick as well, I must admit. It's nice and speedy, but this wasn't a particularly complex board, as you can see. I looked at this chip and I thought, am I going to be soldering that? Can I do that? And I sort of chickened out a bit, I must admit. As it happens, since this was done several weeks ago, I've soldered that 328 PB in, no trouble at all. So I don't foresee any problems soldering that in the future. And in fact, I've got some here, because I ordered some in preparation for actually soldering them myself. There they are, look. There's 5 there. I don't think it's going to be particularly difficult. You can get those in through hole as well, by the way. So if you thought, I don't like that board with the SMT, you could always change the board. I'll put all the EasyEDA project files for this I'll put up in the GitHub. You can just load them into EasyEDA and just change the components if you want. But as you can see, I've got quite a few here. I wonder what I can do with all those. Yeah, okay, the details later. And the red ones over here, they're unassembled, so they're just well, bare boards, right? You can solder them yourself, just to play about with the dip switches or headers or do anything else you want with them. It all works. There's nothing wrong with the PCB. Now, we mentioned at the beginning that the dip switches were something I wanted to use because I'd seen them in other boards, like this one at the back here. Now, these 2 boards, these are 2 boards stuck together at the moment. I haven't split them yet. This is in fact a pin extender. And I'm guessing this is where I got the idea from, where I've seen these dip switches used before. So I thought, hey, that's a good idea. I can use those. It's easy then to change the values. But then again, it would be easy to change them with pin headers as well and jumpers. So it's just an excuse to use them, really. Or I could have done this. Now, these are standard pin headers, but they're too far apart to put a jumper on, of course. So if you think, well, I don't like the idea of dip switches and I don't want pin headers that are too far apart, if you're going to make this universal timer a fixed timer, which I guess it would be for most things, like my toothbrush, it's going to be fixed 2 minutes, it's not going to change, then you can just put links across the ones you want. And the others that aren't used are automatically brought down to ground by the resistors that aren't actually present on this board. But if you look at the assembled one, all those switches up here will have these resistors to ground. So you don't have to put anything into those links if you don't want to, apart from the ones you actually want. As I say, video 161's got all the details for that, so let's not labour the point. Okay, so I did all that, created this board then with the idea of having a nano that just basically plugs in. There we are, look, just plugs in the top. I thought, yeah, that makes life a lot easier, which means I can then program the nano and stick it back in here. Well, I can program it whilst it's in here, of course, because it's got the USB socket on the front. Although that is being a bit lazy, I've got to admit, it's being a bit lazy because, you know, we can use our Arduino Shield, the Smart Shield, to program any of these chips via the ICSP these days. So, what would I do differently? Well, having done this, and it all works, which I'll show you in just a second. We'll switch it on, and it'll beep while we're doing it. Right, okay, that means it's running. Oh, if you tilt this, you see that? Oh, and the LED flashes. That's in suspend mode. We'll come on to the code in a minute. We'll just let that sit down there. I thought, well, why on earth did I use a nano? The nano is quite big. There's an awful lot of pins on it that aren't being used at the moment, even though I did bring some of the pins out at the top there. And some of the pins here as well for debugging, but because it's a nano, we don't really need these, to be quite honest. You can do it all via the USB. No ICSP header on here because it's actually on the nano itself. Oh, there we are, 30 seconds, timer's up, because I've set this to 30 seconds. And then you get a reminder every 5 seconds that you haven't switched it off. See? Right, now, so what I could have done then is used a much smaller board like any one of these. So this is, I think this is a micro, isn't it? Oh, upside down micro. So that's nice and small, and you can program that using ICSP, I think. Maybe. Can't see an ICSP header on it. Anyway, that means you might have to do it manually, or indeed one of the LGT8 chips that we saw. This is a very fast. It uses a PB chip, but it's the equivalent of a micro. Just put my hand there so it focuses. Now we've been through this in a previous video as well, and it's a supercharged nano, and it just, I don't know, it just feels a bit wasteful really, doesn't it, to have it in the timer, but you can program it via the ISP headers there. So I could have done that, or I could have done something else, which we'll talk about in a future video, what I eventually did. But there's a little bit to talk about on here first, so let's think about one thing at a time before we go and dive into the code. Now, the first thing that this project was going to be is battery powered, and I had the option for putting the battery holder vertically like this, or either under the board like this, or potentially, no, I couldn't have put it on top because the beeper went there. So it was either to the side like this or underneath, and it was always going to be 3 volts because I tested it on 3 volts and it all seemed to work. And the advantage of having the battery on one side, if I don't case this, is that I can stand it like that to suspend the timer for a minute, because occasionally, believe it or not, I do want to switch the brush off and just, you know, spit or rinse or something. Yeah, I know, I'm sorry if you're having your breakfast or something. And that suspends it, and you get that little bleeper sound, which I'll show you. Did I not demo that? So you get that beeper. You also get on this demo a flash. But yeah, that's where all the problems arise. Now, I don't know how well you heard that beeper, but I'm quite disappointed in its volume. At 5 volts, brilliant, no trouble at all. 4.5 volts even, great. 3 volts, a little bit on the quiet side, and you have to make very sure that the beep you're putting through here is at the resonant frequency of this beeper thing. And I've got my doubts about this beeper. I don't think it's a piezo beeper at all. It looks like it should be. If you look through the hole, it should look like a piezo with some sort of resonant chamber, but the current this sucks, as does that LED. But then LEDs are LEDs, that can be switched off because that's on a different pin. But this I'm not so keen on, and so I thought maybe I should swap that out for a proper piezo, a bit like this. I've got a whole selection of piezos, all different sizes, with their little sounder chambers on. So basically they're all flat discs. I think I've shown you these before actually. So they're all flat discs like that, and you can buy them like that, just the flat disc, but then you won't hear them unless they're mounted on something. You have to stick them on something. So if that was a bare naked piezo, you'd have to stick that onto a case or something like that, and then it would resonate and it'd be fine. But these come with, these come with a little resonant chamber, so you can hear them, and they work fine, no trouble at all. But once again, even especially if I want to use the little one, they're not super loud. Oh, I'll put links for all this stuff in case you want to have a look. Okay, I can't remember where I bought those. It might have been Amazon actually, that one. But anyway, it's not that loud either, because we're limited by the fact this is a 3-volt battery. So I thought, okay, needs must. You've made a design error here, really, because you didn't really test out this beeper, even though it's a 3-volt beeper. I didn't really test it out on 3 volts, and when I ever did test it out, it beeps. So I thought, fine. But that volume is just not enough, because I do have the radio on when I go into the bathroom, and yeah, it could easily be missed. The whole point is I don't miss that beep. So I thought, right, okay, I've got some options then. I can take off that battery holder, that 3-volt, and put this 3-cell AA battery thing underneath, and it's almost the same size as the PCB actually. Not that way, that way. So it's pretty much the same size. I'm a little bit cack-handed on camera here, but you can see that. And of course it does make it quite a bit bigger, but then if this is, some sort of enclosure, it wouldn't be noticed. And at 4.5 volts, it all runs as you'd expect it to run, nice and loud and everything else. Or I can go down to an AAA 3-cell holder, which is smaller. Still fits underneath, but obviously is smaller. A little bit more compact. And finally I thought, do you know what, there's got to be a better way of driving that piezo, because remember that video we did a little while back on the LED flasher running on 1.8 volts. I thought, well, if we can run an LED on 1.8 volts by sort of doubling that voltage with that diode pump, what can we do using PWM and that beeper? Funny you should ask that. Let's see what the solution is. Now it turns out I didn't have to look too far, so rather than me reinventing the wheel yet again, good old Tim Eckel has already created this Tone AC Arduino library, and very good it is too. Now I've only done it on a breadboard, and then I took it all apart without showing you because I thought we wouldn't have enough time. We'll cover this potentially in a future video when I do the enhancements of this board. And what it says, the bit that caught my eye, of course, is that it says here, look, nearly twice the volume, because it uses 2 out-of-phase pins in a push-pull fashion. And as he explains, of course, if we're generating a PWM pulse, the PWM pulse can't actually go below 0, but the way it works, if one is positive and then the other one is positive, if you like, so you've got 2 outputs, it works in pretty much the same way as the diode pump, and you get twice the volume. Now, as it happens, I haven't actually implemented this yet into my code, but maybe I will have at the time we do the follow-on video to this one. And I'm hoping that it works as I expect, because then I can keep my 3-volt battery rather than put that clunky great AAA thing on it. And not only that, of course, instead of using one of those piezo beepers or whatever that is on this board, and as I say, I'm not convinced that is a piezo because it takes too much current. Rather than that, I could actually use a little tiny speaker that I also have, and that looks like this. So we have 2 candidates here. The one on the left, I'm assuming is a speaker, a proper speaker, not a piezo. Difficult to tell without testing it out. And the one on the right is a proper speaker, mini tiny speaker. I think it's 8 ohms or something. There it is, 8 ohms, 0.5 watts. One of those will probably work quite well. Now Tim Eckel says in his readme, he says always put a 100 ohm resistor in series with one of the lines so you don't burn things out. So obviously it does take a little bit of current, but I'm prepared to sacrifice that, because if I manage to run on this 3 volts, it just makes the whole thing a lot more portable, really. And I'm only using it 2 minutes in the morning, 2 minutes in the evening. It's 4 minutes a day. As it stands, it's taking about 6 milliamps whilst it's running, because I'm not going into deep sleep or anything like that, for reasons I'll explain in a minute. And yeah, and of course, well, as you notice, as soon as I switch this on, the LED comes on from the Nano. Now, I have tried removing the resistor. Well, not tried removing, I did remove the little tiny resistor next to the power there. So that one there I removed, and it brought it down to about 4 milliamps. And I thought, there's probably other stuff on this Nano board sucking some power. You got LDOs on the back and the CH340G and stuff like that. And I thought, well, I don't really need any of that, so why is it on there? Do I rip all that off? Well, we'll come on to that. But as I say, having LEDs on here is not brilliant, and that one there, that one really does suck the power. Peak power at the moment, when it's running like that, goes up to 16 milliamps. Just as a pulse, you know, as that flashes for 50 milliseconds, which is quite a drain, isn't it, on that poor little battery, even if it is only for 4 minutes a day. So, speaker though, on there instead of that, if that takes slightly more current to have that beep, but we'll switch the LED off instead, then I'm happy with that, and we'll just see how that goes moving forward. I mean, at the moment, this is a fully functional universal timer. So I think the best thing to do now is look at the code and find out what I'm doing with this and how easy it was to have the timing mechanism just run perfectly. So the code is pretty simple, and we'll look at that very briefly now. I'm not going to go through every single line of it. Right, we are using SPI, of course, to communicate with the 748C165. That we've been through that, so I'm not going to go through it again. Basically, what you say via the SPI lines is, go and load the values, please, from the dip switches, and give me the value back. And it just does it, just like that. Okay, more sounds effects. Okay, and you can read up about all that in video 161. So I'm just going to skip all down here until we get to the setup. Anything in the setup? Oh yes, I've tried switching on all the power savings you can possibly think of, which is basically, you know, switching off I2C if we're not using it, and we're not, switching off the analog to digital conversion if you're not using it, all that stuff like that, just trying to get the power down. And basically it didn't make a lot of difference because I'm not in deep sleep. I'm not in any kind of sleep mode. In fact, it's just running, and I suspect the LED's probably taking more power than anything else. So yeah, didn't make an awful lot of difference, but we'll cover that in a little bit more detail later when we get down to there. Okay, right, now this is the interesting bit. If you notice here, I've said timer. Set it to timer. What's timer, you ask? Good question. Let's have a look. So this is timer, and it's written by Bruno Calu from Brazil, and it basically does what you'd expect a timer to do. What his usage example is that you create a timer object, and then you say, okay, timer object, I want you to call a particular routine in my sketch every X milliseconds. You specify milliseconds. The example he's got here is every 1,000 milliseconds. Here we are, look. So you say timer, set interval 1,000. It goes, okay, so every 1,000 milliseconds you want me to do what? And you go, I want you to call, and that we set the call back here. I want you to call that routine that I've written. There's a little function that you'd have written called hello callback, which he's written up here. Okay, so every 1 second in this case, this routine hello callback is called. And the way he's got it here is that it'll just run forever. Now in your loop, all you do is update the timer. Now it doesn't matter if your loop, you're whizzing around your loop 1,000,000 times a second, which will be something on a Nano, I can tell you. But anyway, if you were, it doesn't matter. All it's doing is updating an internal clock within that timer object. And then that will decide, oh, it's time to go and call that routine. As long as you do call it regularly enough. If for some reason you were to use delays in your sketch long enough to prevent it being called, it would not call it in time. So if you've said call that callback here every second, which is what his example says, and then in your loop you said, oh, go and display an LED, light up an LED, and then delay for 2 seconds, and then continue. Well, the poor little timer has now lost its opportunity to call back because it hasn't had the timer updated. So basically, adding in delays, blocking delays like that is a bad idea. Capital B, capital I. A small delay, 100 milliseconds, I could, yeah, okay, that's fine. 50 milliseconds, 100, yes. Any more than that, though, chances are your timer will not get updated in time. And it will be late. It will still call it, but it will be late. So that's the basic way you set it up, and it's all very simple and self-contained. Now, if you notice his routine here, hello callback, it's a void and it's got no parameters. And I thought, in my particular example, I'd like to call a beep every 30 seconds for a certain duration and a certain frequency. And I thought, I tried putting in here some parameters, so basically brackets, parameters, and of course it wouldn't like that. The syntax was all wrong. So I emailed him. I said, Bruno, thanks very much for your library. Great. It's just exactly what I want, except can I put parameters in? Here's a way of doing that. And he said, of course there is, Ralph, you idiot. No, he didn't say that. He just said, yes, there is. He says, you've got to use a lambda expression, which I'll show you in my code, and it's the most simple thing in the whole world. And lambda expressions I've used in my C#.NET world, programming world, but never thought that C++ would allow me to do that on here. So let's have a look at my code again and see how I've implemented this. Right, back in the code, we've done the interval then for every 30 seconds. We've done this callback for 30 seconds, no parameters on that one. We've started the timer. You must start it, otherwise it won't run. And you go, that's it. And then we just wait. Now, every 30 seconds, this callback here gets called. There's some debugging stuff in here. It says callback and all that. So here we say callback, and this is part of the lambda expression. You've got square brackets, open brackets, squiggly bracket, all the code you want to run, close squiggly brackets, close brackets, and that's it. That is the syntax of it. It's creating this lambda function here that is the key, though. And as you can see, even if you don't understand or want to understand how lambda instruction works, that is the way you do it. The other way to do it, and the way I was doing it before he replied to me, was have a wrapper routine. So I wanted to create a particular beep in a particular routine, but I couldn't put parameters in, so I created another routine that had all the parameters in and called that instead a wrapper routine, basically. But this way is, as you can see, a lot neater, and you can put multiple statements in, just like writing another program, really. So that's how you do lambdas in his timer. Okay, everything else is pretty straightforward. The play tune thing that it plays at the end of the 2 minutes, and that's stolen from the Arduino playground because I couldn't be bothered to work out all the notes. But if you notice here are all the notes, look, defined in my header sketch. That also is stolen from the Arduino playground because I certainly wasn't going to work out all those. The bit that's highlighted there, actually, that's around about the resonant frequency of this beeper. It's around about 2K, 2000 Hertz. So I was playing around with the notes in this area to make it sound louder. And yes, it does sound louder at those notes, but still potentially not loud enough. Yeah, the power saving, we mentioned that right at the beginning of the video, didn't we? To power save, you can switch off the analog to digital conversion, which I did. I've put all my pins as input pull-ups. Now, we've had a few comments about this. Should you set them as outputs and low? Outputs and don't set them as anything. Inputs, don't set them as anything. Inputs as input pull-ups. I've tested everything out and check things out on the internet, everything, and basically it doesn't seem to matter whether you put them as output low or input pull-ups. It's the same effect. So I'm thinking, what's the safest? Output low, but then if you put something onto that pin accidentally, you're going to sink all that current. Or if you put it as an input pull-up, nothing's going to happen. So that's what I've chosen. It's input pull-up. That didn't make any difference hardly at all. And when that did make a difference in previous videos where I'm going in deep sleep, it made probably about 10 microamps difference. So in this case, because I'm sucking 6 milliamps out of that battery, you just wouldn't see it at all. So here's another way of disabling the ADC converter, because this is all built in to the power.h library. I'm disabling the USART because I wasn't going to be using it. I'm disabling timer 1, but I can't do timer 0 or timer 2 because that's used by the timer routine. And I'm disabling I2C. None of which made any difference, well, no significant difference, let's put it that way, to my power savings. The timer library has a few other options you can put on there. I suggest, if you're interested, you go and have a look. It's far, far better than trying to write your own. Thanks, Bruno, for that. It's great. Right, I've plugged in the unit just so you can see what's coming out of the serial port. And over here, you'll see the results. Now, what this is doing then, it's reading the last 4 bits of that byte coming back and saying, oh, you've selected 2 lots of 30 seconds. That beep you just heard was one of the 30 seconds times up. All right, now that I can hear because it's now running on 5 volts. All right, so yeah, nice and loud. And in another unit of 30 seconds, so the next time it comes to that callback, it'll go, whoa, hang on, we've reached the end of the timer. I'm not going to beep. I'm going to play a little tune instead and then remind you to switch me off every 5 seconds or thereabouts. So if we just hang about, didn't have to hang about very long, did we? Right, and now in 3 seconds time, 2 seconds, 1, it's going to beep. There we are. That's the reminder. Switch me off. I'm wasting power. And it's important, this, isn't it? Because it is using up a lot of power, relatively speaking, for that coin cell. So yeah, fine. Let me switch it off. Oh, can't find the on-off switch. Oh, that's because it's powered by the USB port. I can't switch it off. Now what are we going to do? Right, that's it for the day. It's a simple little demo. Shows what needs to be thought about in some projects though, doesn't it? I never would have thought that 3 volts would make that 3 volt beeper so quiet, frankly. But I'm going to try out that tone library from Tim Eckel, see how well that works. And yeah, other things are going to change on here as well. Now, if in the interim you think, do you know what, I wouldn't mind playing about with one of those boards. Guess what? Yes, I have quite a few here to give away. I think JLCPCB were kind enough to give me 10 of these boards. Now I need at least 2, one for my toothbrush, and we've just bought a new toasty maker, and that needs a 5-minute timer, which is not built in, so I'm going to take one for those, for that item. And there was one more, and I can't remember what it was. So there's probably about 6 or 7 of these to give away. This is with the SMD stuff already mounted. All right, so you don't have to do any soldering apart from the through-hole stuff. And I have got 10 blank boards. Now you'd have to do all the soldering for this. So if you want one or the other, let me know. And you know where the details are. Yeah, it's in the About tab. All right, by now you should have found it. I'll try and put a more useful link. I'll put a link in a pinned comment that goes directly to the About tab on my channel. You just scroll down the page a bit and it says business inquiries, click here for the email address or something like that. All right, click that, that'll show you my email address, and I'll get your email. So just send me your email. Yes, I'd like a board, please. Tell me which one you'd like. Now, problem, if everybody says yes, I want the pre-soldered one, then we're going to run out in about 3 seconds flat. Yes, if you do request one of these, but one of these is no longer available, please let me know whether you want an unsoldered version in its stead. But if you think there's not a chance I'm ever going to solder any of these components, SMD components, then state that, and I won't send you a red one at all. You just unfortunately have to miss out in that case. But if you can solder and want to play about with this, with the nano plug-in and all that, it's all very easy to do, and probably worthwhile. I mean, if you don't understand, you know, parallel load shift registers yet, now's your chance, isn't it? Okay, right, that's it for today. I look forward to hearing from your comments below, not just because I like to hear from you, because I think YouTube keeps track of how many people comment, and they go, oh, that's quite a lively little video, that's good, as it does most definitely with likes. If you go, yeah, I like that video, well, it's nice for me to see that, but much more importantly, it's nice for YouTube to see that, and they go, oh, that looks like a popular video, I'll offer that to a few more people. So likes if you like this video. Don't forget to send me your details if you want one of those boards and tell me which one it is, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.